One thing to mention, if we are not on the screen, you cannot hear us. We cannot interact through voice. So then you can only use private chat.
Okay.
So just so you know.
Okay.
But yeah, there should be no reason. Okay. I think we got another 5 minutes, so we're good.
Oh, okay. So it says I may want to use Firefox to share my screen. Oh no. So
yeah,
I'm
you
using...
can already. Yeah, can you share your screen maybe just to check?
Yeah. So I was. Yeah. So I clicked on it to check. So I clicked on share screen, and then it says there's a bug in Chrome that may cause things to crash. So you may want to switch to Firefox. Yeah, that was what I was thinking. I was like, oh no.
Well,
let me. Okay.
We've tried it through Chrome, and that worked quite okay.
Yeah.
I'm currently working Microsoft Edge, the latest version. So
yeah, Edge works fine. We had it working with Chrome. The only
So
thing is,
when I-
first time yeah, go ahead.
Yeah, so when I share my screen, so there's no need for me to click the share audio. I believe that's talking about system audio. So I'll just go ahead and click on share.
Yeah.
And can you see my screen now? Can you see?
Wait, I'm going to
Not
add
yet.
it to the stream, and
Okay.
it should come here.
Yeah, you can see this.
Yeah, we should. Yeah, we can see it nice and clear.
Nice, good. So got everything all set up. Good.
Good and crisp.
Yep.
Yeah.
That
works fine. So let me switch.
So Nick, we cannot intervene during when David is talking, or if someone is asking something only through the private chat channel, or.
So the private chat channel is for us to communicate amongst each other. So this is not the chat happening with.
Yeah, I know, but I mean, like, if there's something going on, we can unmute our mic and then just intervene quickly to say, like, people are not watching the screen or whatever.
No, unless I add you actually to the stream.
Ah, okay.
Yeah. So, yeah, I'll be monitoring also the private chat if there's anything that you notice or that I notice, and then we can jump in if needed.
Okay, then.
Yeah.
So you're going to announce David now this time, and then I will do Danny the next.
Yes, indeed.
Okay.
So alternate. Is that good?
Yeah.
Yeah, perfectly.
Yeah. I think you'll have the last one, right? You'll have Ginger at the end at 11.
Yep. But yeah, you're also there because you need to do the manual control. So.
Yes, I'm. I'll be behind the scenes.
Which tool are you using for the broadcasting? Is it OBS?
StreamYard.
This is using StreamYard.
Oh, StreamYard, okay.
Yeah, and so then the StreamYard flow goes into a platform that we're using also for Microsoft Learn TV.
I see.
Which takes care of like right now, if there is nothing happening, basically the switching over at the top of the hour, those kind of things, to include like recorded sessions. As soon as we end our broadcast here, it automatically picks up and rolls some other content. All of that stuff is happening behind the scenes. But like for presenters, StreamYard is the entry point.
Nice.
Okay, cool.
Yeah, but I think the previous Virtual Azure Community Day, we used OBS.
Yeah.
We got 1 more minute. Checking. So YouTube has another half a minute before it should roll the preview, like the teaser video. So I'll put an overlay in the meantime. So we're still. So the teaser video starts now. So we should be up in like 1 minute. So I'll put an overlay right now while the and then I'll switch it explicitly onto on this view here as soon as we go live. Welcome back to Virtual Azure Community Day. And so we're back here now from Belgium with our hosting team. So we'll be hosting you until midnight. So I'm Nick Troch. I work for Microsoft as a developer, audience PMM. And my co-host is Chris.
Hey, hello, good evening, everyone. Well, evening for us in Belgium, of course. Welcome here. We're taking over for the Belgium one. We're going to do the next 6 presentations till 12 midnight, Belgian time. And, well, happy to have you around. I'm Chris. I'm from Belgium, and I'm also one of the partners user groups here in Belgium, mainly Azure. And, well, welcome. Enjoy your stay this evening, and I hope you will learn a lot of cool stuff.
Yeah, and just a reminder, if you've just joined the sessions here, if you have any questions for our speaker, and we have David coming up in just a minute. If you have any questions, feel free to post them in our chat window, and we'll make sure that David can answer those. So let me introduce David. Welcome, David, to Virtual Azure Community Day. It's great to have you here. David is a security consultant, independent consultant, and he's been active in security and cybersecurity for close to a decade. Created some courses, so he's a trainer. Created some templates for you to help you with your security. And David, quick question: how actually did you get started with security? I'm always triggered by people that are focused on security and cybersecurity in particular. So, what got you into security?
So it was just something that I sort of fell into. So it's something that I joined an organization that happened to be one of the top cybersecurity firms in the world. And I happened to be working for a manager that happens to be a very bright security guy. So the manager is currently the CISO of the organization that I'm referring to. So then we sort of just formed a team off of that. We started our own security project, our own security work, and things just sort of just took its own life from there.
Yeah. Okay. Cool. So it almost happened by accident.
Almost by accident. Yeah, I'll say that.
Okay.
Yeah.
Cool. Well, without further ado, I'm gonna give you the floor, and have a great session.
Yeah. Thanks very much. Thanks very much, Nick and Chris, for that introduction. And by the way, can people see my screen? I'm just wondering my screen it's sharing, right? All good. So. Thanks very much, everyone. So, hello, welcome to this Virtual Azure Day community talk. So, I hope that you're all doing okay in the current conditions. I hope you're keeping safe as much as possible. So, today I'll be talking with you about how vulnerable is your Azure environment. And the approach that I'll be taking will be, we're going to go through a breach scenario, a recent breach scenario. And at the end of that attack scenario, we'll come to some conclusions of some lessons to learn at the end of the scenario. And this will be a different approach to what a lot of the Azure security talks, at least the ones that I've seen, tend to focus on. So quick information about myself. My name is David Okeyode. I'm an independent cloud security consultant, as Nick mentioned earlier. So I help companies to secure their Azure environment through private expert level trainings and assessments. I have over a decade of experience in cybersecurity and over 6 years of experience as a trainer. And I hold over 11 professional certifications across the Azure and AWS platforms. So that includes the Azure Security Engineer certification and the AWS Security Specialist certifications. I have a blog that I maintain called azurehangouts.com. I have a YouTube channel, and you can also check me out on Twitter. So let's get right into what we're talking about today. So security is one of the key pillars of a great Azure architecture that, alongside performance and scalability, availability and recoverability, efficiency, and operations. And security gets talked about a lot when we talk about cloud architecture, when we talk about design, when we talk about cloud development. Security gets talked about a lot. And kudos to Microsoft for this, actually. So Microsoft is actually one of the cloud providers that stands out because they've really put a lot of emphasis on security for Azure and other Microsoft cloud services. And so kudos to Microsoft for that. But as I mentioned earlier, I'll take a slightly different approach today from a typical Azure security talk. But why am I going to be taking a different approach? I think that it's important for me to just give a bit of background as to my reasoning behind this. So there's a reason. A lot of presentations and talks and videos that I've seen on Azure security, they've been about best practices, about how to use tools like Azure Security Center and Azure Sentinel. And there's nothing wrong with that. You could go on YouTube or Channel 9 today and see thousands of videos that focus on this already. And we definitely want to be educated on best practices to follow. We want to be educated on how best to use security tools in Azure. That is critical and that is important. But equally important is understanding attacker behavior. That's an important part of cybersecurity education. What are the tools? What are the tactics? What are the techniques? What are the procedures that attackers use to exploit our environment? What exactly does an Azure breach look like? That's an important part of cybersecurity education, right? That's why we have disciplines like ethical hacking. It can help us to turn on the light because there may be times where we do not see the reason why we should follow certain security best practices, but seeing how that could be exploited can help to switch on the light in our mind. And my third reasoning for that is also to learn from failures of others. So it's important to learn not just what to do, it's also important to learn what not to do. There's actually a proverb from where I came from. So I am Nigerian and I am Yoruba. And there is a proverb that says, Ikuto pa ojugba ini, owelong pafuni. So that's a Yoruba proverb that's translated as, when death strikes your mate, it sends you a strong message. And what that means is, whenever we hear of any breach in the public cloud that's going on around, we should not laugh at the organizations that happened to and think how silly they are. What we should be doing is, what are the lessons that we can learn from this? And that's sort of like the approach that I'm going to be taking today. So whenever we talk about adversary tactics and techniques and procedures, the MITRE attack framework usually comes up. And the MITRE attack framework, for those that may not be aware, it's a globally accessible knowledge base of adversary tactics, techniques, and procedures, or TTPs they're referred to. And it's a fantastic site to check out, right? So what you're looking at on the screen right here, so this is the MITRE attack matrix that covers the Azure platforms. And what you can see on the screen are different stages of an attack and methods that an adversary could use at different stages to exploit our Azure environment. And again, I urge you to check out the site. So I have a shortened URL on the screen that you can check out. But when I talk about this, I like to use my own attack matrix, as I have more flexibility to be able to move things around, right? And this is the matrix that I'll be using today. Also, things don't typically flow the way you see them on the screen in the real world. But in many cases, things don't happen this way. It's not unusual for Recon to happen right after initial access again and to keep happening all through the attack chain. So that's not something that's unusual. So it's not something that's all set, like things have to follow a particular pattern. It's things that it's flexible and an attacker can adjust tactics and methods depending on the environment that they find themselves in. So here's the scenario that I'll be walking through today, and then we'll come to some lessons at the end. So here's the attack scenario. We have an attacker system and we have a victim environment. All I know about this environment is that they're hosting an application in Azure. And that's all that we know. But at the end of the whole scenario, we'll end up with this, where we'll have used different methods and different tactics from what I've showed you on the screen earlier. We're using those different methods to exploit the environment, to steal tokens, to open backdoors, and just using other methods to exploit the environment. But before going further, a quick warning. So when we're performing this sort of engagement or this sort of attack scenarios, it's important that we operate within the boundaries of what is allowed. And here is a short URL that I created to the link where Microsoft has clearly documented what is allowed and what is not allowed from a pen testing perspective or from a vulnerability assessment perspective. Essentially, any attack that could impact on other Azure customers is prohibited. So for example, doing a distributed denial of service attack, that's a no-no, that's not allowed, right? So anything that could potentially impact on other Azure customers, it's not allowed. So make sure you operate within the boundaries. And failure to operate within those stated boundaries can lead to a suspension of our Azure account or even a termination of our Azure account. It can lead to legal action being brought against us by Microsoft. It could even lead to financial liability claims being brought against us. So that's something that we want to pay attention to and make sure that we always operate within the allowed boundary. So do check out that link for the rules of engagement and what is allowed and what is not allowed. So, but every attack stage, no matter what you're looking at, always start with a recon, right? So that is where an attacker is trying to identify potential targets. They're trying to determine the target surface area, what services are available to exploit. They're trying to identify the versions of the services and many other things. They're trying to understand the target vulnerability. And essentially what this case is about, it's about learning as much as possible about the environment, right? So it's about finding potential targets, but also about learning as much as possible about the target environment and what services are running. And in Azure, there are multiple ways that an attacker can use to find our services that we are hosting in Azure. There are different ways that they can use to identify that. So one of the ways is just a cloud provider IP range scan, right? So when Microsoft publishes a list of Azure public IP addresses, this can be downloaded from Microsoft website. So you can go on Bing or Google and search for Azure public IP address, and you'll be taken to a link where you can download a JSON file that contains a list of all these public IP address. So an attacker can go download this list, for example, and just pass that list to try to identify targets that are live and responding, right? So maybe do a quick network sweep, do a quick check of which services are listening, right? So for example, here's a sample query that we're using JQ to pass the JSON file that we downloaded from Microsoft website and to filter that down just to IP address ranges for the UK South region. And we could even filter that down further. So for example, here's another query where we are filtering that down to say, only filter that down to IP addresses in UK South that are used by the Azure App service. So we can even filter that down for certain services that we're interested in. So that's on the side of just an IP scan and IP sweep. There's also the cloud service discovery. And this is talking about platform services. How do attackers know what platform services that we may be running, right? There are many ways that an attacker could use to find out which platform services that we have in Azure. But it usually has to do with DNS in one way or another. That's because Microsoft makes use of several domains and subdomains for Azure platform services. So for example, here's a list of some DNS suffixes and their associated Azure services, right? So you can see on the left-hand side, the DNS suffixes, on the right-hand side, the associated Azure service that uses that DNS suffix. And here's a continuation of that list. And this is not by any means a comprehensive list. This is just a quick overview. There are many other services that uses other DNS suffixes. So, but what does an attacker do with this? There are different options or different methods that they could use. So for example, an attacker could take the DNS suffix and could do a DNS enumeration. So what that could mean is an attacker could probe your public DNS zones and then see if you have records that references Azure aliases, some of the suffixes that we talked about earlier, and then see if you have that. right? An attacker could also do a search engine query. So maybe that could be Google, that could be Shodan, and just any other DNS search engine to try to query and see if anything has been found that's active. Another way is an attacker could also do a DNS brute force discovery, right? So that could be where an attacker builds a word list that they think that your organization may be using, and they just do a DNS brute force to see if they get a response, right? And there are many tools that are available to use for this. There's Hammers, there's DNS Recon, there's Alt DNS, and just many tools, just a variety of free tools that could be used for something like this. Excuse me. It's important to note, though, that when we're talking about Recon in this stage, whether the IP sweep or the cloud service discovery, this is just information gathering. This is not a vulnerability. This doesn't mean anything is wrong. This does not mean there's a security loophole. So let's move on. So because one of the first things that we're going to be doing with the scenario that we're going to, we're going to be doing just a cloud IP, we're going to be doing the vulnerability scan, but we're also going to be scanning a potential target for application vulnerability, dependency vulnerability. So here's a visual representation of what I'll be doing. So I have my attacker system. I'll be doing a service scan and a vulnerability scan of that attacker system, and then we'll see what we find. So if I go over here to VinCorp Visual Studio, so what I have is this is my attacker machine in Visual Studio Code. So I'm already logged into that. So let's go just one step back. And the first step that I'll be doing is, I think this is something that I may post to GitHub later, but I want to post it with instructions of how to build both the attacker system and the victim environment, so you can practice this sort of by yourself also. So I have that that victim environment. So if I go ahead and just run a quick nmap against that victim or that potential target, and while that is running, I'll just talk about what I'm doing here. So the -v for nmap, I'm specifying the verbosity level of the information that is going to throw out on the shell. So the A parameter I'm specifying to try to detect operating system and services that are potentially running on this target. So, and the -sv, I'm using that to specify a service detection, try to detect the service that's running. And I can also specify the intensity of the scan that it's going to conduct. So, and I'm specifying level 5 here. So, and that's what nmap is going to do. So nmap is an open source tool that you can download for free on the internet, and it's typically used during Recon stages. Excuse me. So that's run, and it's thrown out a bunch of messages. So let's go have a quick look at some of this. So I've got to move quickly here because we have a while to go. So there's some good information that I'm seeing on screen. So for example, I can see that port 80 is open. This is it's showing Microsoft IIS, HTTPD. It's showing that this is running a WordPress site. So WordPress version 5.2.4. It's also showing that port 443 is open on this, and it's showing me information about the certificates. I can see that it's .azurewebsite.net, so that potentially just an Azure Hub Service or an Azure function, and many other information that we could go into more details to look at. But let's just go with, we currently know that this is running a WordPress, the WordPress engine. So what we can do then is, now we know what sort of service that's running, we can sort of try to do a vulnerability scan against that. And that's the next step that I'll be doing. So which I'll copy that, and I'll go ahead and run a vulnerability scan against that target. So let's clear the screen and let's run that. So what I've also done in the backend, so is I've linked this with the WordPress vulnerability database. So I got an API key from the website, and I've already loaded it in. So that's what it's doing, is it's making use of that database to determine vulnerabilities. So if I scroll up a bit, you can see that it found two main vulnerabilities that's detected against these potential targets. It found an authenticated shell upload vulnerability, and there's another vulnerability that it found, which is, let's see, the cross-site scripting vulnerability. So actually, let's scroll up a little bit. I believe that there should be other vulnerabilities. And here's another vulnerability. So here's another vulnerability detected by the passive detection. And we have a remote code execution vulnerability here. So remote code execution vulnerability is one of the worst sorts of vulnerabilities you can get. It essentially allows an attacker to execute code on the vulnerable target. So let's move on very quickly. So right now what we found out is, let's go back. What we found out that our target has a remote code execution vulnerability. So the next thing that I want to talk about is let's talk about credential theft. And so when we talk about credential theft, we're referring to techniques that an attacker can use to steal credentials like account name, passwords, and tokens from potential victims, right? And the same techniques that are used on premises applies in this scenario. So the same techniques apply. However, there are some techniques that are unique to an environment like Azure. So a good example of that would be something like credentials in configuration settings, which is talking about services like Azure App Service settings or Azure Functions, or some other services like Azure Automation Variables and others. Another one that could be unique in terms of credential theft being used in terms of methods in Azure would be something like a managed identity token theft. And I will talk about those very quickly in a minute. So let's talk about Azure App Service setting. So Azure App Service setting it's a feature of the Azure App Service that's used to pass variables as environment variables to application code. So it's where we can go under configuration of the app service and we can pass certain variables to it. So any values that we pass through this method, they're values that if someone is able to compromise that environment and run a printf, if it's using the Linux service plan, they can essentially dump out any variable that we've passed in through this method. And also, if they're able to execute something like a printf in that environment using something like remote code execution, it could give certain environment variables that could point to the potential to exploit something further. So for example, if we do a printf and we get the identity header or identity endpoint environment variables, that indicates that the managed identity is associated with whatever instance that we've been able to compromise. So that's what that's referring to. Talking about managed identity, what is it? So managed identity is used by Azure services to access other Azure services. So there are many ways that we may be able to implement authentication for services that needs to be able to access Azure services. But one of the most secure ways is to use a managed identity to implement that. But this could also be exploited. So an attacker can exploit that and steal the managed identity token. So if you have a look in the example that I have on the screen, I have an Azure App Service that needs to be able to access application data in Azure Blob and needs to be able to access some key in Azure Key Vault. So the first thing that we do is normally we create a managed identity. We'll give the necessary access to that managed identity. And whenever our application that's hosted within that service needs to be able to access whatever resources that it needs to be able to access, it can make a call to a local token service and it's going to obtain a token that it can then use to access that. The thing again that we're going to see is that if an attacker is able to compromise the service, this token can be stolen, which is what we're going to go to see next. So what we're going to go to see next is those two options that's being used. So we're going to take advantage of this remote code execution. We're going to take advantage of that to dump out the configuration settings or the application settings of this app service. And when we dump that information, it's going to reveal to us that there's actually a SQL database behind it. And then we're going to try to exploit that and take advantage of that, right? One of the other information that we're going to be able to find from that is that there is a managed identity that's also attached to that. So let's go have a quick look at that. So let's go move very quickly because of time. So if I go back, so what I'll be doing is trying to exploit that vulnerability. So let's clear the screen. And I have certain payloads that I've prepared. So without going into too much details again because of time, so it's just scripts that I'm going to cause the application to execute and then return the results to us. So I've got about 4 of them here. So I've got the one that I'm going to be using to dump the environment variable and the one that I'm going to be using to try to exploit the managed identity. So let's go to run those. So let's go back to Visual Studio Code. I'm just going to jump straight to number 2, which is the credential hunting. And I'm going to copy that. And I'm going to execute that. And I'm going to run that. So that's spit out a lot of information to us. If I scroll up, you see that initially what it's done is it's dumped out every environment variable for this app service. And as part of that, there's some really juicy information here. So I can see that this app service has a database that it's using. I can see information about the database connection string, including the username and the password of that database. So this is very useful information. So I'll just copy that. So I'll copy that because I will be using that. So the other information that I can find here is I can see it spit out some information about the MSI endpoint. And when I see this, what this shows to me is that there's a managed identity that's associated with this instance. So again, that's very useful information that I'll make a note of that we're going to be using afterwards. Let's go back to, I need more space to get. Okay, I thought I dumped out the other one now, but that's fine. Oh, so that's why I did not copy what I thought I copied. So let's go copy those again. That's better. Let's go copy the other thing that we saw was identity header. That's something that will be useful to us for managed identity. So let's copy that. The other thing that we found was the database information. So let's go copy this. And what I'm going to do is I'm just going to try to connect to this database that we've just found. We found the username and the password. So I have my SQL Workbench already installed on the Windows VM. So what I'll do is I'll copy the database server name. So let's copy that. And I have my SQL Workbench. So if I go ahead and bring that up, let's go ahead and add a new connection. Let's call this ActDB. Enter in the host name, and I'll also copy the username and the password, or the user ID and the password that we're able to dump out. So user ID and the user password, or the database password, sorry. And store that in Vault, put that in there, click OK to that. Let's test the connection. It says connection successful. That's that's interesting, right? But that happens a lot actually. So if I go ahead and double click and open that, so now I'm connected to this database now, right? So I can go ahead and click on schemas, and I can see that this database server has two databases inside. It's got a sys database, and it's got the other database that the application is probably using. So one of the things that we can do is I can just go ahead and just dump the content of this database. So I can select that database. I'm going to export it into a self-contained file, and I can just start the export. And I'm just going to dump the entire content of this database. So now if I go back to the location where I dumped this, let's go to that location there. So apologies, I know that this may be really small for people to see. So apologies for that. So, but if I go over here and if I bring that up, and there you go. So I've dumped the entire database, and that's something that we can actually begin to explore and look for credentials within this database if they are not stored securely. So for example, I can do a quick search for admin and see that there's a few references to admin that I can find on this list. So, and maybe that's going to be pointing me to a password. So let's go, here we go. So that's pointing me to something that's, yeah, so that's pointing me to a WP user stable. I can see an admin username. I can see the hash of the admin password. And again, we can just obtain like that information. We're able to connect to that. But that is good. What we want to do is we want to take that further to try to establish some persistency in the environment. And what we're going to do is we're going to try to exploit the managed identity. And we're going to see if we can steal a token that will give us more access to Azure. So what we'll do is we're going to use this identity header and the MSI endpoint. We're going to use it to craft a script that's going to be executed on the server. And this is what that's going to look like. So it's going to look like we're going to make a request to the local token endpoint, and we're going to specify the identity header that has specifically been put in place by Microsoft to bypass SSRF type attacks. We're going to try to make use of that. So let's just go over to Firefox. I've got the exploit file open here somewhere. So I'll just go to that exploit file. I'll go to do some edits against this. So making a call to the token endpoint, but we need to replace the identity header because that's different, and that's something that Microsoft rotates continuously. So I'm just going to go grab that identity header. I'm going to go over to Firefox, and I'm going to paste that in there. So actually, it's the same thing. So if I go ahead and save that, so that's saved. So let's go run that exploit. So let's go over to that, and let's go copy, add the name, run that, change the target, cause it to execute that. And if we scroll back up, you can see that we have a bearer token, we have an access token. So if I go ahead and copy that access token, so let's go ahead and copy that information. And I'll just open the new file to paste this token into. And there you go, ladies and gentlemen, we have our token, our first token that we've just stolen from this environment using a combination of just mistakes made by developers, inputting sensitive information in application settings, and also probably just overprivileged identity. So let's go ahead and move on to the next step. So once we have our token, what can we do with this token? If you still a bearer token for an Azure environment, of what use it is, or is it, sorry. Well, we can go ahead and just make calls against the Azure API. So there is the Azure control plane API endpoint, which is management.azure.com. So we can interact with the API if we have a valid token that's been issued to an authenticated entity. So once an entity has authenticated and has obtained a token from Azure AD, once we can grab that token, we can use that token to make calls against the API and essentially just assume the permissions that the user has. So here's a sample request of what that looks like. So for example, we can make requests, specify a bearer token, and then specify the endpoint, management.azure.com, and the URI, the host, and the resource path that we want to make queries against. So that's what I'm going to be doing next. So let's go to do that. So the first thing that I'm going to be doing is I'm going to be storing this in a variable. So I'm going to grab that token. So I don't want to be typing this or copying and pasting it every single time. So what I'll do instead is I'm going to go to my attacker machine. Let's clear the screen. Let's move, give it a bit of space. And I'll type in token equals to the bearer token. And if I press enter to that, so now I've stored that in a variable, so I can go ahead and reuse that. So the first thing I'm going to do is I'm going to just try to list the subscriptions for this Azure environment. So let's go copy that. Add the environment. Let's run that with JQ, of course, to format the JSON reply that we get back. And here we can see that this environment has one Azure subscription. We can see the subscription ID, the tenant ID, which are really useful information, right? So now we are having a list of the subscription. We can begin to store that subscription ID in a variable also. So because that will allow us to be able to easily reuse it. So let's go ahead and clear the screen. Let's run that. Let's run that. So now we have that subscription ID in a variable. So now we can begin to easily reference this. So again, let's clear the screen. Let's get a list of the resource groups. If I go ahead and copy that. And if I go ahead and run that, and there you go, we got a list of the resource group. We've just passed in our token and our subscription ID. We got a list of the resource groups that are running in this environment, right? Let's get a list of the resources that we have in this environment also. So let's clear the screen. And if I run that, I can see a list of the different resources that we have in this environment. So it's listed, at least the ones that this token has permission to be able to read. We have those information here. But one of them stands out as very interesting to me. because it just gives us opportunity to be able to go credential hunting again. And if I scroll down carefully, you notice that there is an Azure function that's hosted somewhere here. So here we go. So there it is, an Azure function hub. And that is the function hub ID. So that allows us, whenever you see something like function hub, automation account, maybe a resource group deployment, all those sorts of types of services in Azure, there are opportunities to go credential hunting and hunt for credentials and see if people have exposed credentials there. So that's what we're going to do with this function. So we have the function ID. Let's go on for credentials and see if someone has left the credential open on that function. So what we're going to do is we're going to make a call to that function resource group. So we got that resource group and we got the function name. So all of that looks good. So let's go copy that. So what we're doing is we want to dump out all the configuration of this function and see if a token is also exposed under that. So let's clear the screen. Let's run that. And we have all the different configuration settings that's been set for this function. And while looking through this, something jumps out. So for example, we have a case where someone has passed a client ID and passed a secret key over to this function. Maybe it needs to be able to access certain services and people have used that instead of using a managed identity, for example. So what we can now begin to do is we can now begin to load in that second credential and see what we can do with that. So let's go back to our slides and let's see where we had, and let's bring everything to a close. So if I go back to where we had now, so what we've done is we initially stole the token from the managed identity of this app service. And then we found a function that has a service principal ID and a secret key, which gave us another key that we can work with. So we're going to load that key and we're going to use that key to make requests to Azure. And I'm going to be doing that using a tool called Lava. So Lava, as far as I'm concerned, is one of the best kept secrets for Azure security. So Lava is a Microsoft Azure exploitation framework tool that was inspired by, if anyone is familiar with Pacu for AWS, so it's an exploitation framework. If you're not familiar with Pacu, maybe you're familiar with Metasploit, which is popular. So it's sort of like a Metasploit or a Pacu for Microsoft Azure. So it contains multiple exploitation modules for pen testing Azure environment. So for example, it contains modules for Azure AD, for storage accounts, SQL databases, and different modules to perform privilege escalation, persistent data exfiltration, and other stuff. And the view star behind this is Matthew Votlevy. So Matthew, I'm not sure if you're on the call. Shout out to you. Thanks very much for creating this awesome, amazing tool. So Matt's Twitter handle is at Matt Votlevy. So if you are on Twitter, just follow him. Again, this is an amazing tool. I'm surprised that this has not been talked about a lot because it's an amazing tool. And I'll show you a little bit of it in a minute. So that's also the GitHub repo to download Lava and to use it. So again, I'll encourage you. I'll put out a YouTube video afterwards on how to use it, how to install it, and how to use it as part of like exploitation. So that's what I'll be doing. So I'm going to be using Lava for that. So I already have Lava downloaded and installed on this attacker machine. So let's clear the screen. The first thing that I'll do is I'll use the information that I just found now. So let's go. I need to run that again. So apologies. Oh, actually, let me run that again. Run that, and I'll just copy the main information that I need. The client ID, tenant ID, and secret key. Because I need to log into Azure CLI and then use Lava to exploit that. So the username will be the client ID. So if I go ahead and copy the client ID and paste that there. If I go ahead and copy the secret key that's been passed here. Let's go ahead and paste that there. And for the tenant ID, if I go ahead and copy that. So that's one that we stole from an Azure function. And if I go ahead and put that in here. So if I go ahead and copy that and just use that to log in. So that's successful. So that's good, successfully logged into that. So now we're going to exploit using Lava. So first of all, I'll go to the directory where I have Lava. So cd Lava, and then I'm going to run it. So it's written in Python. So Python 3 Lava, and here I am in Lava. So if I want to list the modules that exist, I can use just a simple ls, and it's going to list all the modules, the data exfiltration modules, persistence, SQL, and all the others. So for example, if I want to run a module, I just put exec in front. So for example, if I want to list all the storage accounts, I can just run, so if I go on the storage account module, I can just run exec storage.list account list, and that's going to run that module. So if I go ahead and run that, it's going to use the token that I just stole, and sorry, it's going to use the identity that I just stole, and it's going to use that to list out all the different storage accounts that exist in this environment. So that's all well and good. So what about we want to start dumping, we want to start doing something more interesting. Let's start dumping all the storage account keys that exist in this environment. And that's the power of a tool like Lava. With just a single command that way, we can just get as much information from an environment that's been compromised. So run that, for example, it's going to go through the environment and look for all the storage account keys that the identity that we stole has permissions to, and dump out all the keys. And now we're going to have all the keys for all the storage accounts that we have access to, right? So we can even start dumping out blob container contents that this identity has access to. But I'm more interested in showing you much more interesting stuff. So let me show you the one for the storage accounts. I'm sorry, for the SQL database. So let me first list all the SQL servers that exist in this environment. And I can find one SQL server, and it has a database in it. So what I'm going to do is I'm going to list all the SQL databases that exist. So if I go to run that module, let's just go ahead and run exec SQL DB list. So it's listed all of that. So let's go ahead and try to open a backdoor to that SQL database. So what we want to do is we want to add a firewall rule that will allow an attacker machine to be able to access that database from anywhere. So if I go ahead and execute that, it says, hey, which target do you want to add this to? And I can see that I've got a SQL server called victim SQL server. I go ahead and copy that target name and put that target name in there. Says enter the name for the rule. I'll call this backdoor rule. And the IP address that I want to add, so 1.1.1.1. If I go ahead and run that, and it says it's added that, and I can go to verify that. So for example, if I go to the environment, if I go under SQL servers, and if I go under the victim SQL server that we just exploited now, and if we go under firewall and virtual networks, there's a rule that's been added that allows 1.1.1.1 to be able to access this database from anywhere. So that's sort of thing that we can do, right? So for example, we can even gain remote code exec on virtual machines that we may have access to. And this is going to be using the run command capability. So for example, there's a Windows virtual machine that exists. So let's go copy that. Let's go run that. And there you go. I've got PowerShell access to this system. And what it's done there is it's using the run command capability to be able to execute commands remotely. So we can start installing malware and start doing many other things. So that's sort of like just giving you quick information about that. So I'm running out of time now. I'm almost out of time. So let's just bring all of this to a close. So how the scenario that I just described now, that's actually an attack chain that happened recently, right? So that's not something that's unusual. That's an attack chain that happened recently. So how to prevent? So for example, in the initial access phase, we use the remote code execution vulnerability in an environment plugin. We used it to exploit the environment to begin with. Application and system vulnerabilities are still one of the main entry vectors into cloud environments like Azure. So ways to prevent, remember, we're not talking about detection or any of that stuff here. We're just giving a quick lesson to learn from this. Vulnerability assessment from development to production. Static code analysis, open source code vulnerability scan, passive pen test all the way from your CI/CD phase all the way to production. You do your own vulnerability assessment, detect the vulnerability before an attacker detects them. You could have, there may be a case where it's not practical for you to quickly fix a vulnerability that you found. So, it's recommended to have a mitigation option. So something like a web application firewall, application gateway as a web application firewall that you can use from a regional perspective. Azure Front Door has a web application firewall that we can use from a global perspective. So take advantage of those. Azure has many native vulnerability scanning capabilities. So for example, there's a VM vulnerability assessment capability that uses Qualys, but you only get that if you have security service standard. There's also a container image vulnerability capability that integrates with Azure Container Registry that we can use to scan vulnerable container images. So check those out, but make sure you have vulnerability assessment from dev all the way to production. That's important. So in the credential theft, we're able to dump the configuration settings found in credentials to access a database. Enforce secret management is important. And where do you enforce secret management? There are actually certain hotspots. I call them credential hotspots in Azure, like DevOps too, like Azure DevOps. We're using Azure DevOps variables. You're putting secrets there. Azure App Service configuration setting, function configuration setting, automation account variables, resource manager deployment output. People are putting secret information in all these different places. That's not good, because if there were to be some credential that's like exploited or a vulnerability that's exploited, attackers know to look in those locations to hunt for credentials. So again, we're going to start all the way from development, not just say put something in place in production. So start all the way from development. So for example, there's a tool called the ARM Template Test Toolkit. So let me quickly bring that up. So the ARM Template Test Toolkit is a free tool. Again, I'm going to be putting up a YouTube video on this. It's a free tool that we can use to assess our ARM templates before we deploy them. It's actually the one that Microsoft uses to assess templates, the Azure Quick Start template. But it has some capabilities when it comes to this. So for example, what's the name? Secure parameters can't have hard-coded defaults. So it's going to look for those kind of capabilities before you actually deploy the template. It can check if you're outputting secrets in your deployment outputs and fail your deployments because you've done that. So again, put in place this sort of tests, not just go straight to production. However, it's also important to use Key Vault for all secrets. So use Key Vault as much as possible. Here's an example of referencing Key Vault, or referencing secrets in Key Vault on the configuration settings. Also, do not expose your databases to be accessible from anywhere. Right? Use something like the service firewalls together with a private endpoint wherever possible to sort of restrict where they can be accessed from. So for example, when we store the token, we're just able to connect to the MySQL database and start dumping it. Credential theft and the impact. So we also used a stolen token from managed identity to exploit the environment. Follow the principle of least privilege always. So the token that we stole had too much permission that it should not have. Only give permission to resources that need it. And more importantly, even read-only permissions are dangerous. Read-only permissions could give permission to be able to read the storage, to be able to read other sources where an attacker could find credentials. So even read-only permissions are dangerous. So only give permission that's actually really, really needed. So that brings me to the end of my presentation and my session. So thank you very much. I hope you found that interesting. Again, I'm open to answer any questions if there are any, Nick and Chris. So over to you.
Thanks a lot, David. Been checking the questions. There are no questions so far, but it has been quite a terrifying session, to say. To see how easy you can get to those credentials was somewhat terrifying to me. Maybe a question I have is, well, it's a continuously changing landscape, I guess, attack vectors and the different ways that people try to discover information about you. Yeah. What are good resources to get basically get an update of where should you be looking out for these new attack vectors and ways that attackers can get into your systems, yeah, as a security person?
Yeah, very good question. So the one that I really like, right, that I like and I follow a lot, there's a Slack channel called it's called the Cloud Security. I'll post this somewhere, right?
Okay,
So the Slack channel, and it's a group. I believe it has probably about 500 over 500 security professionals only, right? So it's by invite only. So, but we share a lot of information on that Slack channel, and it's a very useful resource for me. It actually made it to some top lists as one of the go-to places for cloud security. So it was founded. So there's a section there for AWS security, but there's a growing section there for Azure security. And whenever there are like news about exploits or breaches in the cloud or in Azure, we're constantly trying to look at how that applies in the Azure context and trying to share that information with one another. So that's like the one that comes to mind that's different from the normal Microsoft ones. Microsoft also has good sources, which I'm happy to share some links also, but the one that I enjoy the most is that Slack channel.
Yeah. Okay. Cool. Thanks. A question here I have from Taiwo, and also a comment from David saying, "Wow, it's been a really great session, and kudos for taking this alternative approach, which I liked as well." A question is, can we get the links that you had in the slides and the slides in general? Can you share those as well?
Yes, I can share the PDF of the slide, so I'll do that. So I'll share the PDF of the slide. So I'm not sure where would you prefer I share that? I can share them on Twitter, put them on GitHub or somewhere.
Yeah, if you could, you can share it on Twitter. So we shared basically your Twitter profile in the chat, and if you can share them, if you can stick along in the chat here for in track 2, and post some links in there, that would be great. That would be excellent.
I will do that. I'll definitely do that. Yeah.
Okay. Thanks. Thanks a lot. Many thanks, David. It has been a very insightful session, and looking at the feedback, people loved it as well. So
thank you very much.
Thanks.
Thanks.
Have a good one. Bye.
Bye, everyone.